Hi, welcome back to Kirsty's Virtual Classroom. Today in California Geology, we are talking about the Great Valley Sequence. Okay, so we're looking at the Great Valley, which comprises of the Sacramento Valley and the San Joaquin Valley in the center of California. So to give you some references, the Sierra Nevada that we just talked about is over here to the east, and then it's bounded by the west by the Coast Ranges. And the San Andreas Fault runs through the Coast Ranges and down into Baja California. The population of the Central Valley is about 7.2 million. And by 2040, we're looking at 10 to 15 million people living in the valley. It is 650 kilometers long, about 80 kilometers wide. There are approximately 15 million acres, and the agriculture production in 2019 was 50 billion. There are more than 400 commodities in the region, and our annual rainfall is only 5 inches in the south, but 30 inches in the north. So in Fresno here, we're about 10 inches on average. The main development after the 1850 gold rush was early cattle farming, dry grains, and an intense irrigated agriculture. So I already mentioned some of these facts. So we're 430 miles long, about 75 miles wide. The Great Central Valley is actually two large valleys, which is the Sacramento Valley and the San Joaquin Valley. So the San Joaquin Valley is drained by the San Joaquin River, and they flow together to form a massive wetland, which we now use as main ag sources for the area. And then the Sacramento Valley is in the northern portion, and it is drained by a major river, the Sacramento River, and then it flows out into San Francisco Bay. So this geomorphic province, more than any other, has been altered by humans. It is in its unspoiled state, it contained 3 communities of plants and animals. We have valley grassland, freshwater marsh, and then riparian woodland. Those are the 3 different types of ecologies that we might see in the Central Valley that is not altered by humans. So the origin of the Great Valley Sequence began as a basin formed due to subduction on the west coast. So we talked about that forearc basin that is between the accretionary wedge and where we saw magmatic intrusion into the continental crust. So the basin gradually filled with sediment over time, both oceanic and continental, to create the rich soils of California. So the Central Valley is a geographic location. The Great Valley Sequence is a geologic body of rock. So we looked at this several times already. Remember, we have the ocean floor subducting beneath the continental crust, and that is creating a subduction zone complex where we see accretion in the trench, and that accretionary wedge becomes the coast ranges towards the late Mesozoic. And then we see the Great Valley Sequence forming in the forearc basin between where we have our accretionary wedge or our subduction complex and our Sierra Nevada uplift of the plutonic rocks there. So here's another look at a forearc basin. So the Great Valley group would have been underwater for some time as the subduction zone was initiating. So we have the oceanic crust subducting beneath the continental crust. The magma in the mantle is upwelling to create continental volcanic arc, which would later be known as the Sierra Nevada. And the accretionary wedge is accumulating in the trench, creating the Coast Ranges subduction zone complex. And then the forearc basin would eventually come to surface once water receded and we lost the subduction zone. Give you another look at this. We have the continental volcanic arc occurring, the forearc basin, the subduction zone complex, and the actual subduction zone. And again, this is around 130 million years ago. This is what that snapshot shows. So the Central Valley is this forearc basin zone in here. So in the Mesozoic, because the Central Valley was still underwater, there were a lot of different critters around, or creatures around that we wouldn't normally see in the Central Valley today. So today we're worried about kit foxes and coyotes and things like that. But in the Mesozoic, because it was underwater, we saw a lot of plesiosaurs, a lot of mosasaurs, turtles. There were still a few pterodactyls and dinosaur type creatures roaming the earth. And towards the end of the Cretaceous, we saw the disappearance of all of those animals. But we find fossils in the Fresno area that indicate and suggest that we were underwater during this time, because the plesiosaur and the mosasaur, which he's kind of cut off here, they were underwater or swimming animals. And so this area had to be underwater when they died and were fossilized. So this is a mural at Fresno State in the Science 2 building. If you ever want to visit, you can go take a look at it. It's pretty awesome. And then below here, there are some fossils sitting on the ground. So Plesiosaur was one of those animals that has been found, or fossils that has been found in western Fresno County, particularly in the Penoche Hills area over kind of near I-5. So we're looking at West Fresno County, where we saw a lot of plesiosaurs, indicating that there had to have been some sort of water there at some point so that these guys could swim. Another indicator is the mosasaur. These have also been found in the same location in western Fresno County in the Penoche Hills. These mosasaur fossils are similar to what you would maybe think of a modern crocodile, but they are massive, so they can be up to 40 feet long. And the Hadrosaur was a kind of a mixture. So he would have been probably closer to when there was a transition between sea and land. They are the ducky, basically, version from Land Before Time. That's what he or she, excuse me, was supposed to be a hadrosaur. This is an adult version here. They are basically like a duck-billed dinosaur, and they have also been found in the Penoche Hills. So one of the other ways that we know is based on that we were underwater during this time is based on the sediments that are present. So in sedimentary environments, we see on the east side delta shallow marine, which is sort of like the Mississippi outlet, so the Mississippi River outlet. The west, we see deeper marine sediments. So that's how we know that on the west side, we were underwater for sure, or the Central Valley, excuse me, was underwater for sure, other than just the fossils, is that the sediments there are indicative of deeper marine environments, or depositional environments. So the Great Valley was a shallow ocean basin in the Mesozoic to early Cretaceous, so 100 to 200 million years ago. And it mainly filled with material eroded from the Sierran volcanoes. So the volcanoes that were in the Sierra Nevadas at the time. And then rocks in deeper formations are rich in volcanic fragments. Rocks in shallower formations are mainly composed of minerals derived from erosion of granites. Okay, so that'd be the erosion of those Sierran volcanoes. The northern Great Valley Basin started filling up around the time of the Sierran volcanic arc died off. So around 80 million years ago, we saw a lot more material coming down into the basin and starting to fill it up. And it was completely terrestrial around 20 million years ago. So everything was above sea level by that time. That doesn't mean that we didn't have inland seas or old lakes left behind, because we did. The southern basin was actually underwater for much longer, until about 2 million years ago. The Central Valley is a huge basin filled with sediments. We already know this. Most of it is sand and gravel that is over 30,000 feet deep, that lies on the Sierran basement rocks. So below us in the Central Valley, if you go down 30,000 feet plus, you're going to hit some of those granitic rocks. Okay, but we have 30,000 feet of rock or gravel and sand above us, or above that. which is pretty thick sediment. The deepest part of these gravels are the marine sediments that have accumulated since the late Jurassic time, about 145 million years ago. And this is, again, where we see all of those fossils in western Fresno County. So if we kind of look at what that would be, so we have the Sierra basement rock over here underneath the Sierra Nevada. We do see a slight faulting along a normal fault along the western front of the Sierra Nevada. It's not as significant as its eastern front. And then below, or sorry, not below, to the west of that, we see the sediments in the Central Valley. So below the Central Valley, there is the continental sediments that are derived from the erosion of the Sierra Nevada. And then below that, we see the marine deposits. And the marine deposits are from the Four-Arc Basin Formation. So when the Central Valley was a Four-Arc Basin and not yet the Central Valley, terrestrial Central Valley, it was underwater and there was a lot of marine life here. And so those marine sediments accumulated over a long period of time and created this really thick kind of base for the Central Valley. And then eventually when the water receded and the accretionary wedge was pushed up higher as the coast ranges, it kind of landlocked the Central Valley or this Four-Arc Basin. Continental sediments started to settle in the valley, and then we saw the loss of water in the Central Valley, and now we just have rivers and really no lakes anymore in the Central Valley. So as time progressed, sediments built up from constant turbidite flows and erosion, similar to landslides, but underwater. These flows are eroded in the rock record, or recorded, in the rock record, telling part of the story of the Great Valley Group. So if we look at what a turbidity current is, so if we're looking at like a continental shelf, so let's pretend that this continental shelf is the old Four-Arc Basin of the Central Valley. There are some submarine canyons, and those are areas where material can fluff off or fall like they would in a landslide scenario. And if this happens underwater, we get something called a turbidity current. And what happens with these turbidity currents is they form turbidites. And turbidites are basically rocks that have a series of grain sizes that range from fine to coarse from the top to the bottom. So the bottom is going to be all of the coarse material, and then towards the top it fines. The reason for that is because if you put sand or any kind of material in water and shake it up and wait for it to settle, the heaviest material is going to settle first. And so you see the settlement of the heaviest material to the finest material. The closer the material is in density to water, the longer it's going to take to settle. And so all of the fine material will be towards the top of a deposit. So here's a look at, this is a really hard one to see, but this is an example of some of the turbidites found in the Central Valley. And we tend to see a coarse to fine separation between the material, and this is a series of turbidites. Actually, all these lines are separated events that occurred. So over the last 5 million years, sediments have accumulated in these alluvial deposits that washed out from the Sierra Nevada. These deposits are only a few thousand feet deep over most of the valley floor. Depths up to 10,000 feet occur in some places, indicating that the valley floor was not always as monotonous as it is today. The only topographical relief in the Central Valley is the Sutter Buttes in northern California. So this is north of Sacramento here. So the Great Valley sequence is trapped beneath sediments of the San Joaquin Valley, and they are rich oil fields. The oil fields are primarily in the southern portion of the San Joaquin Valley. There is crude oil that is pretty thick, and it results in a high-cost, low-price product. When oil prices drop, it is not economically feasible to pump oil in the San Joaquin Valley. The current surface outcrop that we see is this yellow coated rock here is mostly all just sediments and alluvium. These overlie the Great Valley, the Mesozoic Great Valley sequence, which is thousands of meters thick. The Great Valley sequence was deposited in a basin on the western side of the Sierra Nevada volcanic arc in the Four Basin, and the floor of the basin consists of the Sierra rocks to the east, Coast Range rocks to the west. So we can look at another image of this. This is mostly quaternary material. There is some Paleogene from the Sutter Buttes up here in the northern portion of the valley, and it's bounded by Paleozoic and Mesozoic rocks in the Sierras and Mesozoic rocks in the Coast Ranges. So the Great Valley sequence, which lies beneath the floodplain alluvium that we see today, is a sedimentary basin with mostly thicker side on the western portion. It can be up to 20 kilometers thick, and it's thinner on the eastern side. If you think about it, one of the big reasons it's thinner on the eastern side is because of the uplift of the Sierra Nevada. So as the Sierra Nevada is uplifted by the Sierra Nevada frontal fault system, the material on this edge starts to, by gravity, fall further to the west. So the material in the Great Valley sequence is much thinner over in the Sierra Nevada side, on the eastern side, than it is on the Coast Range side. The rock types primarily are sandstone, shale, and some local conglomerates. The sedimentary environments, like I've said before, on the east are delta shallow marine, and on the west, deeper marine sediments. Here's another look at this. This is a cross section. Here is the San Andreas Fault to the west, and then the Kern River Fault over here to the east. This is the Kern River. We have a lot of alluvium deposited, some San Joaquin deposits, and a lot of different, just fluvial, different types of environments where most of it is sand, silt. There is some clay deposits, especially in the Tulare area. So this Tulare deposit here is a lot of clay. If you've ever been to Tulare, you've noticed that when it rains, the water sits on the surface a lot longer than it does in, let's say, Sanger. Sanger will actually allow water to percolate a lot quicker because there's a lot more sandy material over there than there is in Tulare, where it's a lot more of clay. Clay does not accept water as rapidly as sand does. So looking at some of the paleogeography, approximately 700,000 years ago, we had Lake Corcoran, or Corcoran Lake. So this was the main lake that was left over after the Central Valley became more of a terrestrial environment. And up until about 100, 200 years ago, there were still some remnants of the lake present in the valley. So if you've ever talked to an old ancestor or grandparent, they might have remembered taking boats up and down the Central Valley. They would have to be around prior to like 1900. So along with the plesiosaurs, the hadrosaurs, and mosasaurs, Central California had many terrestrial animals. These fossils were first discovered in the 1980s at the Fairmead landfill in Madera County. The landfill was scraping to build new disposal cell and hit something hard. It turned out it was a mammoth tusk. And the mammoth tusk is actually one of the mammoth tusks is held at Fresno State, and they take it to the fair in October every year as well. Since then, hundreds of fossils have been found in the area. Madera County built the Fossil Discovery Center to showcase these fossils. So this is a mammoth fossil at the Fossil Discovery Center. They also have some of these fossils down in the LA Basin on display. So here is the Fossil Discovery Center. If you ever want to visit, it's a cool place to take your kids or your nephews or nieces, grandkids. So the Pleistocene California, this is what many scientists believe kind of would have been the environment in the Central Valley or Madera County specifically during the Mesozoic. This circulated around 2010 and shows short-faced bears, some mammoths, some saber-tooths, kind of interacting. So let's look at some of these fossils that are terrestrial in nature. So many of these have also been found in other geomorphic provinces, like I mentioned, some in LA Basin, but these are particular ones that we see predominantly in the Great Valley sequence. So the giant short-faced bear is very common. This is not your typical bear. On all four, he is the height of a human. On its back hind legs, it is twice the height of the average person. We have the Smilodon. The Smilodon, or saber-toothed cat, is California's state fossil. He's not as big as you would think he would be. He would get up to maybe about 4 feet in height on all fours. But those canines would take him about 3 years to actually grow in full. And so the cubs actually stayed with their parents a lot longer than you would see normal tiger or leopard cubs today stay with their mothers just out of protection until their full canines came in. And then the mammoth has been found several times. This is similar to an elephant. They are built a little bit better to withstand colder temperatures because they lived in the Ice Age. And they are much larger than your standard Asian or African elephant. They had the large tusks and a very thick wool coat. So the Great Valley sequence, the most important part of this is that it has very rich soil. And that rich soil is today used for very, very heavy agriculture use. And so we use the Central Valley for growing crops for basically the entire world, which is really cool to say. And you should be proud of that, despite our issues with groundwater and being in a drought consistently. But we have a really cool history of how the Central Valley formed, from being a forearc basin and kind of being situated between these really large mountain ranges, the Coast Ranges, and the Sierra Nevada mountain ranges, and being able to drive 3 hours in either direction in the state and be in a completely different ecosystem. So with that, I will leave you with the Great Valley sequence. I will catch you guys in the next video. Bye!